Okay, good afternoon, folks. This is basically the second lecture for you in week 4. And we're going to be starting a new phase in the type of things that we have been doing for the past 3 weeks. And that is called analysis of an assembly. So let me give you an idea of what I have in mind. So we have a shaft like that, which is, think about it, inserted inside of these two bearings. And the bottom of the bearings, the bottom of these two bearings are clamped, and you apply a force to this shaft. Now, first of all, the way it's done in the book, the way the force is described, is not a realistic one. So the question is, how do you apply this force? So what I have done, or what I will be doing in this particular presentation, is I'll make a little stand up here and then apply the force on that stand. A couple of other things, and one is this assembly is made of two bearings, two parts, which are these two bearings, and then a shaft. So there are altogether three bearings, three parts that make this assembly. And when you buy this shaft and stick it into that bearing and this bearing, it is not going to be behaving the same as if this whole thing was casted or machined in that way. Okay? The behavior of taking that shaft, sticking in that hole, and then standing on it is different from making something like that, casting something like that, or machining something like that as one piece and standing on it. Okay? These are different. Okay? So when you see this, do not go and make a part which looks like that and then do the problem. That is not the problem. Okay? When it says assembly, you have to make it as an assembly. Now, the other thing is that when it's done in the book, I'm not using symmetry. So as you can see, when you look at this problem, definitely you can cut it along that length. Along that length, you will cut it. In the transverse direction, you may or may not be able to cut depending on what you're doing at the two ends. If the two ends, identical things happen at the two ends, then of course you can also cut it like that. First attempt, do not cut. Make it like that, just like it's done in the book. Okay, let's go ahead and start the problem. Are there any questions? Quick question before we move on. Okay, no questions. Very good. We start with a product file, so not a part, because there are two different ways that we can do that. You can make the parts individually, bring it into the assembly, and put them together. That's one way of doing it. I don't do it like that. These are such simple parts that I do it right in front of your eyes in the product. Okay? In real life, that doesn't happen. Parts come from different engineering firms, from different, manufacturing plants, etc., different all over the world, all over the, I don't know, continent, and then somebody has to put it together and make an assembly. But these are all very simple things, so we do it right in front of your eyes. So product, and immediately I save it. So file, save management, save as, desktop, new folder. This is, I'll call it assembly. How about that? Assembly, and what is that? June 1. Okay, everything is going to go here. Now the name, because I want to do it possibly 3 different ways, I'm going to call it, first of all, your ID number, 1, 2, 3, 4, 5, 6, 7, 8, 9. Today you're ranking. And first I'm going to do it with no symmetry. How about that? No symmetry. We say okay. And we say okay. Then I am going to insert a new part in there. And I'm going to name this thing to say right-click properties. I'm going to make it, how about right bearing, okay? Right bearing. This is a part, right bearing. And right bearing. 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 Say okay. Now, by the way, notice that the left bearing and right bearing are the same. So when I make the right bearing, I can use it again on the left side for the left bearing, or I can, I can do it the long way, copy and paste. Okay, these are different. Copy and paste is different than making it or inserting an existing component. Let's not worry about it right now. Or let's make it. So first you have to go to the part design. There is the part design. This is an assembly design. You want to go to part design, just double click on this, double click on this line, it'll take you to part design. Notice that you ended up in part design. Of course, this was a generative shape design because we were dealing with this part design. There. Okay? I'm going to make it. So on that vertical plane, I will sketch. Now my dimensions are here, I don't know, 2 inches, radius 1. Okay, very good. Excellent. So I'm going to make it nice and symmetric because I'm lazy. Later on, I want to cut it. Down the road, I want to cut it. So I'm going to make it nice and symmetric. Okay. All right, how do I make this thing symmetric? For example, I can say this line, control that line, control middle axis. We can make it symmetric. And by default, this is going to be on that line, obviously. Okay, very good. Okay, so put some dimensions here. I think I said this is 2. Okay, this radius is 1. And I'll make a little hole there. And its radius is also 1. 0.5. Diameter 1. 0.5. Okay. Oh, no, not diameter. Diameter 1. Radius 0.5. Okay, very good. All right, exit. Exit. Pad it. Pad that sketch. 1 inch thick. That's what the problem says. Okay, very good. Now, in order to save this part, if you want to save this part, the easiest way is to go and save the assembly. Go up there, go to the assembly level. Assembly level. See that? Double gear, assembly level. And just click on the floppy. Automatically will save this thing for you. Okay? Now that I saved it, I can use it as an instance. That's one way of doing it. The other way is to do a right-click copy and then maybe paste. Okay? You can do it like that too. Now that I save this thing, let me bring it in and use it again. The difference between copy and paste and using something that you already made multiple times is enormous when you're dealing with a complicated problem. When you have hundreds of bolts, they look exactly the same. If you do copy and paste or make 100 bolts, it takes a lot more space than using one and then inserting it as an existing component. Okay? So I will insert this as an existing component. I go there, insert, but you have to have saved it, and I did. Insert existing component. In there, it says, okay, where is that thing that you want to insert? Well, I had a folder, right? Assembly, I called it right bearing right there. You see this? right bearing. I'm going to use it again. It's going to put it right on top of that. There are two of them sitting on top of each other. You can see that. This is the original one. This is the one that I brought in. And you can always move these apart. You have to go back and review some of the stuff from assemblies. Okay, so I clicked on manipulate. You can use the compass. I don't care. You have to make the assembly as we wanted it. So I'm going to translate this thing along that direction. Right there. You see this? They were sitting on top of each other. Okay, good. Now, why don't we save this thing? Later on, I have to move this thing apart. So let me save this thing one more time. Go to the assembly level. Well, we were already there. Floppy. Is there a question? Unmute and speak, please.
Yeah, I was just wondering how you did that copying again. I didn't catch that.
I didn't copy it. I said insert, existing component. It says, where is that thing that you want to insert? It was right bearing here. I selected it. It puts it right on top of that. As a matter of fact, let me do it for you again. Right bearing again. It's going to put it right on top of that. There's going to be 3 of them. And now I'm going to delete it. How about that? And I moved them apart, by the way. I used the compass. Yeah,
Thank you.
No problem. I deleted it. Okay, good. Now, I want to insert the shaft. Insert new parts. I mean, if you already made the shaft, okay, bring it in, no problem, insert the existing component, but these are so easy that it's better to do it like this. And then it says where? Right there. So I inserted another part, a new part, not an existing component, a new part. Always say no and call this thing shaft. Right-click, properties, shaft. This is the instance name. And this is the part name. CATIA does not call it part name. It calls it part number. I don't know. You're crazy. Okay, let's make it. Double click on the shaft. It'll put you in part design. Right there. And make it. Okay, so on a convenient plane, on that vertical plane, I will sketch. I want to sketch a circle that size. Well, why don't I take it and project it instead? So here, use the project that circle. It's going to project it there, and then you can pad it. Look, if you want to do it different way, if you want to draw a circle, dimension it, blah, 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 no problem. Do it the way you want. I'm showing you different ways of doing it, okay? And I'm going to pad that circle. You see that? Let's say 10 inches. 10 inches. There we are. Now, because of the way I made it, it's in the right spot. If I move these apart in the assembly design, you're out of luck. They're going to stay there. And you have to put assembly constraint to bring them back into position. Now, for this part of the course, that is not critical. We're not going to move these apart. If there is any chance that you have to move them apart, put assembly constraints on it. The last 5 weeks of the course, after the final, it's all assembly constraints, okay? Because we're dealing with an entire new subject there, completely different. It's not finite elements and things like that. But anyway, now let me move this thing and put it there. First of all, oh yeah, I wanted to make that stand on the top. Remember, I wanted to make that stand. Okay, so let's do that. You know what? So that because I want this stand to be nice and symmetric, I double click on this thing, makes it say mirror extend, but do only 5 because I want it to be nice and symmetric, because I want to later cut it with this also. So let me hide that. Yeah, hide that guy. Hide that guy. Very, very good. And on the horizontal plane, I will sketch that little stand that I'm going to put my load on it later on. Something like that. I don't know. Yeah, fine. Yeah, okay. Yeah, make it a little bit smaller. exit. Okay, and then you pad it. Now, I don't want to go that far, so there are different ways of controlling that. For example, you can say more. Let me see now. This one, it goes, I want to make it shorter. Okay, fine, I don't want that. And this one controls the other one. Okay, I want something like this. Okay, all right. Now, we want to save our product. There's the product. Because I'm lazy, I don't want to do it one by one. I don't want to go to file save management, save this and save that. I go to the product, that's an overkill, and then save everything again. Okay. Now, if that entire thing is made out of steel, by the way, my other bearing is in hiding here. I'll bring it out so you can see it. Oops. Hide and show. Hide and show. Okay. Hide and show. Okay, where is this thing not coming out? That's the one disadvantage of sometimes using these things with, well, let me see, this pad must be hiding somewhere. Where is this guy? This one is okay. No, the first one. Oh, this was hiding right there. Okay, good. Okay. Now, I want to assemble this. When you assemble, it's always a good idea to anchor something, okay? And there's the anchor sign. I mean, you have done these things, but 2 years ago, okay, so time to get back to it. Anchor this so that not everything moves in space, okay? Then I want to bring this thing and put it at the end, so I say coincidence between this face and that face, and say okay, and update. There we are. Okay, do the same thing on this side. Coincidence between this and that. You say okay, update. This is still not fully constrained because look at what I can do. I can take this thing and rotate. I can take that part, this part, and rotate it about that line, for example. Look, and it's going to stay like that. If I move these things apart, for example, if I move it apart, we'll take this thing there, take this thing there, and I say update, look at what happens. Well, there are no constraints here, okay? So, so we say coincidence between this axis and that axis, and coincidence between this axis and that axis. And now update, it goes back, but it stays like this, okay? So coincidence, or there are different ways of doing this thing. For example, coincidence between this plane and that plane. There we are. And it cleans it up. The moral of the story is, didn't quite clear it up. Okay, so you probably want to say coincidence or parallel. How about saying parallel? Okay, parallel between this plane. I should have made that guy parallel instead of coincidence. Update. Ooh, oh, let's clean this up. Let's clean it up. Okay, bad idea. So stuff that we don't want. You see, I was trying to avoid these things. Oh, you know what? I made contact. I meant to be parallel. That should have worked. Accidentally, I made parallel. This one. This plane. Accidentally, I selected contact. Should have worked. Didn't work. Okay. Let's bite the bullet. Swallow my pride. Okay, so let me delete this. Let me delete this. I don't know how far I am. Let me move these things apart. Let me see what I did. Okay. Okay, very good. So I'm sorry. So I'm going to make coincidence between this plane and that plane. Okay. And coincidence between this plane And that plane, okay, update. Hallelujah. Bottom line, I don't care how you do it. Let's also do coincidence between this axis because I deleted it accidentally. There. This is what you need. I don't care how you do it. But you remember, if you ever move them apart, and you don't have these things, you have to put it back together. Okay, so this was totally unnecessary if you're not going to move it. Now, if everything is made out of the same material, I can apply the material to the product, okay? The product is going to make all the parts the same material. I don't know, the book says aluminum, I'll make it steel. Metal, steel on the top level, and say okay. So all parts are going to inherit this thing. Okay, very good. Does that create an interference fit? No. Okay. All right, so this is all done. Remember, after you do your finite elements, we are nowhere near there yet. After you do finite elements, you have to give us the product, all three parts, and the analysis file. If you do not send us any one of them, obviously analysis you're going to send us for sure. If you don't give us one of these parts or the product, there's no way we can mark your papers. Okay. All right. So we're done here. So we're going to go to generative structural analysis. CATIA sees three solid parts. Immediately it measures it. It sees the shaft, it sees the left bearing or right bearing, and it sees the instance of it, which is on this side, or copy of it if you ever made a copy. It's going to mesh it. Let's look at it. Right click, mesh visualization. We say okay. There we are. This is ugly. You can see that it's ugly. Okay. So let's go ahead and make it finer. That was the shaft, right? It was the shaft here. And let's make it, I don't know, 0.2. By the way, I'm using the worst element that I can find. You know, I'm using linear. Linear is bad, but it's quick. Okay, that's fine. Let's look at the mesh. That's more respectable. Okay, more respectable. Now, let's save our analysis file. Everything is the same. File, save management. There is the analysis file. Save as. In that folder, and what did I call it? I called it 123, 123, 456, 789 dash assembly, I think. Yeah, assembly. Oh, your name. Sorry, Franken. Assembly. This is going to be obvious. Yeah, assembly, and then lap or lap. Well, that's okay. Just leave it. I don't remember what I called it. Right. Oh, no symmetry. No symmetry. Yeah. That's a good idea. You want that. No symmetry. No symmetry. Okay. Very good. Okay. Okay. And you're good. Okay. So deactivate the mesh. All right. I want to see how many people are sitting there. 87. Okay, good. So now we're going to clamp the bottom, right? Clamp this, clamp that, this side. And you can do it separately or you can do it here. It really doesn't matter. Okay, very good. And we're going to put a force here. I think I said 1,000 pounds, something like that. Let me put, I'm not going to put pressure, I'll put a total force of 1,000 pounds. Right there, 1,000, negative 1,000. Okay. All right. Save it. And we're going to run it, and I'm going to show you that it will bomb out. So floppy. This part of it was easy. It was just like a part. The problem is the next one that is going to bomb out. There. And do you want to know why it bombs out? Okay, if you don't have an idea, just plot the deformation. There you are. That guy has no idea that it's resting against a bearing. It just goes through it like knife through butter. And this is always the case if you have parts, many parts, or two parts at least, that interact with each other, then you have to create connections between them. You remember? Father, son, siblings, student, teacher. First you say, who is related to who? And then how they're related. That's what we did when we tried to mismatch in shells. When the guy was going through the other piece, we created the connections, and then we made it fasten there. Okay. So we deactivate first of all. With these things on the screen, there's nothing we can do. Deactivate. Okay. Now the rest of it, you have to make some assumptions. Maybe the wrong assumptions. I have no idea. You have to go visit the part, go to the place that is being in service, see how they are interacting with each other. For example, one thing we know is that this shaft cannot penetrate this bearing. It cannot go through it. It cannot go through it. As simple as that. So what I'm going to do is I'm going to create an interaction between them, connection. I'm not going to say what kind though yet. So connection, analysis connection, you need two things to pick. One of them is the surface of the shaft that I did. For the second one, hide the shaft and select the surface of the hole. All this says is that this surface and the surface of the shaft are somehow related to each other. We don't know how yet. And I'm going to call this thing, how about calling it shaft? Because there's going to be several of these, there may be several of them, and there will be. Shaft dash bearing. I'll call it left bearing. How about that? How about calling it bearing one? Shaft bearing one. Okay? Shaft bearing one. I'll call it surfaces, right? Surfaces. That's what I did. Surfaces. Very good. Say okay. Now we created it. It's right here in the tree, right there. See that? This is the one that I created. Now I want the same thing happen on the other side. So another one. For the first component, the order is not important here because the other one is hiding. In hiding, you can go get it, or the order is not important. You can do this one first, and then the next one you go get it right there. And we call this thing bearing 2. What did I call this thing? Shaft bearing 2. Shaft bearing 2. That's burning. Bearing 2. Okay. Bring this thing in the front if it's bothering you. Right there. So look, we have two connections here. And we know that one cannot penetrate the other one. We call that thing, actually, I should have called this thing surfaces. Okay, right? Remember I called that thing bearing 2 surfaces. I want it to be exactly like that. Surfaces. Okay, cool. Surfaces. Okay, very good. Very good. Now, I want to say, hey, you cannot penetrate that part. That is called contact. In other words, you cannot go through it. So look under the face-to-face connection now. This was just establishing a relationship. You two guys are related. Now I'm going to say, are you cousins? Are you friends? Etc. So you go here, face-to-face connection, face-to-face connection. Down here, the second one on the left is contact. So I select it. Don't worry about these check boxes right now. Don't worry about them. First learn the basics. That one is contact. Look at what it did. It puts this thingy here. It looks like there's two plates in contact with each other, two surfaces. Say fine. And do the same thing on the other side. In other words, another contact for the second one. Look at, put it on this side too. Okay. And let's save it. And run it again. Say okay. Now what? Well, okay, let's plot the deformation, see what happens. Remember last time it went through it? Well, it won't go through it anymore. But it kind of wiggles in there. As a matter of fact, let me say reset the scale. There, okay, that's better. You can see it better. It won't go through it. But there's nothing that stops it in going sideways. You just bought this thing from Canadian Tire and put that thing in there, and you blow at it. If this is an ideal world with no friction, and the surfaces are smooth, right? All you need is blow at it; it'll start moving. What stops it in real life is the friction, but we are assuming there's no friction. Cancel. So now comes the question: okay, how are these things prevented if there's no friction, for example? How are they already little friction? Let's put it that way. How are these prevented from sliding? Well, this is where you go and we either make some assumptions or go and see how it's done. Let me pretend that somebody took a welding gun and welded the surface, the edge of the shaft to the edge of the bearing. That's one way of doing it. Welding the edge of the shaft to the edge of the bearing. Somebody else might say, oh no, I'm going to put an adhesive around the shaft and stick it in there, and they're going to bond together somehow. Okay, that's also possible, but it's a different kind of interaction that you're describing. So let me do it the way I described. Pretend that there is the edge of the shaft and the edge of the hole are welded together. So first thing you need to do is to create a connection. The edge of the shaft, okay, let me hide this. First component, the edge of the shaft, right there, edge. Oh, I don't want the face. Okay, let me see, something was blocking my view, maybe the circle, maybe the projection that I made. So let me do the following. Let me hide this, There must be something here that's blocking it. No, undo, something was blocking it. Undo. We'll get it, don't worry about it. What is this? Yeah, so let's try it, connection. I don't want the face, I want the edge. Edge, right there. And for the second one, the edge of the sky. Make sure you hide that sketch. There was a sketch there, remember? I drew a circle. And now I select this edge, and edge. And just so that I don't remember, I'm going to call it, how about the, I don't want to call it weld. I will say edge to edge. Edge of the shaft and edge of the hole. You know that. It's a bad idea to save a few seconds and don't put things that make sense, because you're going to regret it later. But, okay, I'll take my chances. Bring this in the front. So I created the connection here and I named it so that I can recognize it, edge, and then go to face-to-face connection again and look for something fasten. You've seen fasten. We did it last on Friday, I think. with that mismatch in shells. Fasten. That guy, notice that it puts a fastener sign here. That has nothing to do with fasteners and bolts and things like that. That means these two edges go together. That's really what it means. Okay, save it. Okay, run it. Okay. This must be my day. It worked. Now, let's plot the deformation. So first of all, I'm going to change the scale. I'm going to change the scale because remember I had to bring it down. Katia has to bring it down so that you could see that this guy was moving. Scale right there. Excellent. And you can animate it. And this is what you expect. It looks good. Doesn't mean it's right, by the way. And do you remember I said that, well, I mean, we can cut it with the YZ plane because everything is symmetric on both sides, but can we cut it with XZ plane? Well, that depends. Did we do the same thing on this side? Hell no. If we had created the connection here and made it fastened, then, of course, this would behave exactly like that side. And then, of course, you can cut it like this too. But not here, because I did not kind of fasten this thing to the other edge. You cannot cut it with the XZ plane. Okay, this looks good. How about numbers? How about numbers? Yeah, numbers like there. Okay, so average ISO. Change the rendering. Material shading. Oh, I like it. That doesn't surprise you. There's going to be a big stress here because it's like a beam bending problem. Like it's almost almost simply supported beam. It's not simply supported, but the biggest stress is in the middle for beams. Okay, I'm sorry. The biggest deflection. This is what I meant. Is deflection is in the middle of the beam. Now it says 0.0039. Okay, is this big? Now this is where you have to plot the stress, von Mises stress. Okay, this is 12,000 psi. 12,000 psi. Yield strength for steel is 30,000 psi. Okay, now look at where it is. That makes sense because this is 90 degree. You're going to have you're going to have big stresses in the middle of a beam. In a beam bending problem, if it was simply supported, the biggest stress is going to be in the middle because the biggest moment is in the middle. Okay, but you also have these because of the sharp corner, and I mean, ordinarily you put fillets there, etc., etc. But it is not quite clear to us where the maximum stress is. So let me actually look for the maximum stress. This M gives you the location of maximum stress. Actually, the maximum stress is inside. It's right there. Okay, because when you think about it, it makes sense. I mean, basically, this is pressing on that, and there's a sharp 90 degree angle here. So, you know, in this particular problem, the way it is, if we trust these numbers, the maximum stress is there. Now, if you say, oh, you know, this I don't care, I don't think this is important to me. What you can do is you can say, just show me the shaft. Just show me the shaft. Double click on it. Go and select the shaft on the selection. Select just the shaft, which was this one. Notice that those ends do not mask this thing anymore. This is about 9,000. All right. Let me put this thing back because I want to cut this thing now. I'm going to save it. Are there any questions? Okay, no questions. I'm going to kill this. I'm going to go to this and save it under a different name. File, save management. Oops. File, save management. Product, you're going to take the product, right? Product, save as. Okay, this is going to be maybe causing a problem for us. We'll see. What is this? This is the product, okay? I'll say with symmetry. We'll see. We'll see. I may be better off if I put this thing in a different folder, okay? So a new folder. Uh, okay, in a new folder, I'll say with symmetry. You'll see why. With symmetry, like that. In there, we say okay. And notice there is something called propagate directory. When you say propagate directory, it means also take those two parts or three parts and put it in there. Put it in that folder. So not only put this new product in there, but take these three parts and put it in there, and they don't talk to each other. Okay? Save directory. We say okay. Let's check it out. Okay? Let's check it out. So where's my folder here? There's the assembly folder. These were the original stuff, my product, my two parts. Okay, actually it's not three because I use instance, existing component, right? And then now you go with symmetry. Yeah, you see that? And if you make changes here, it will not affect these guys. Be careful with doing things like this. All right, so let's go back to this. And now I'm going to start cutting it. Where is the saw? There's the saw right there. Saw, split, split in the assembly. It says with what? Well, I'm going to say with this. It says, look, these parts are all going to be affected. The left bearing, an instance of the left bearing, and the shaft. Do you want them all to be cut? The answer is yes. Cut them. There we are. If you want, you can take the other side. And this will not affect those original parts that you had in the original directory. Okay, so save it. This is all going to be within that folder that we just created. Now we're going to go to generative structure analysis. Remember that it meshes it, and that one
Professor,
was two. Yes?
isn't there another plane of symmetry, or we're not going to use that?
Well, I didn't do the same thing that was done on the left side, on the right side, so I did not cut it. If I had welded, think about it, if I had welded the edge to edge on this side too, there would have been a plane of symmetry except that you said. But notice it came out. You know, the shaft came out.
Yes,
it came
yes,
out of the hole.
Yeah.
So it's not a plane of symmetry.
Okay.
If I had created another connection, or if I create another connection here and make it fastened, then of course this would also be a plane of symmetry. But I'm not going to do that. I'm not going to do that here. You'll see that it comes out of the other end. Now, wait a minute. Let's change this thing to point 1. Okay, I think I made it point 1. Ah, it's too small. Yeah, it's I don't know. Point 2.
For the mesh size, how would you know it's a good number or a bad number?
Okay, now I don't know whether I told you guys this at 8:30. You may belong to lab 53, which probably you had your lecture with me yesterday. I think today I said, look, that's the most common question. I have no idea. You cannot say anything until you start with something and keep making the mesh smaller and smaller and smaller. Watch your results. Make sure they don't change that much. The answer is we don't know. If you took it a micron, it may be too big. So the answer is you can't decide by just making this run. You have to do mesh conversion study to see, have I reached a point where I can trust my mesh? Without that, garbage. That's what it is. Just nice colors, that's all. Did I answer your question? That's, if somebody comes for interview to me, and I was working in industry, that's the question that I ask. How big is big? Let me put it this way. I think I made this example. I bring my friend and I say, this guy is rich. Excuse me? Rich with respect to what? Bill Gates or me? So with having no reference, you cannot do that. And the only way we can find references here is that we make a run, make another run with a smaller element, check the results, see if they're close. If not, both are garbage. Make it small again. Make it small again until things don't change that much. But be aware of the fact that making things small everywhere is nonsense. You know there is nothing important here. So if you're going to make it small here, and we know how to do that, or make it small at that end where the action is. Don't make things small in there. You can do that, but it's ridiculous. You don't need it. Okay, let's move on. Deactivate. We don't have this. Okay, let me change the rendering here. All right, let's do everything that we did before. So clamp. Clamp. You made a cut. Don't forget the surface slider. Surface slider. You made a cut here. You made a cut up there. You made a cut in the shaft. You made a cut on this side. You made a cut there. So you need surface slider on all of those. And you put a pressure. You put a 1,000 pound up there. And the other direction. Minus 1,000. Minus 1,000. Come on, guys, speak up. Speak up.
So you use the force, not pressure.
I use the force. I'm sorry. Oh, cancel. Oh, okay. Force. Sorry. That's what I want. That's what I meant. 1,000 pound down. Speak up.
Yeah, that's awful.
What should it be?
500?
Yes. If it was pressure that I applied, don't worry about it. Okay. Now, believe me, if you don't make those constraints or connections and do it the way we did it, it's going to fall. It's going to go through. It's going to cut through it, etc. So now that we know what we have to do, why don't we go and do it? We create two connections. General analysis connection patiently between the surface here, and hide that. For the second component, don't forget to select this. Second component, that surface. That's the first one. And I'm being really lazy here. I should call this thing surface and surface bearing. Okay, I'm being lazy. I'm not going to do that. So for the other one, the surface of the hole, the order is not important, remember? And the other surface is hiding. So I think it was this one, right? Okay. And let me bring this thing in the front. Actually, we're going to have to hide it in just a second. Let me put this thing in the proper view. Now, remember, we made an edge-to-edge thingy here. Let's hide this garbage. Hide. No. Hide. Okay. So another connection. See, I'm trying to save a few seconds, and I'm not going to call these things, give them names, and then if I ever need it, you're going to have problems. So first component is this edge, okay. And the second component, the one that I hit, let's bring this thing back in the front. That's the easiest way of doing it. Hide the bearing. Select this. That's easier than, yeah. So we created three connections. The first two are contact. The last one is fasten. So let's do that. Easy. Face-to-face connection. Contact right there. First one is contact. See that? This little gadgets. Next one is contact. That gadget on the other side. You see this? And finally fastened. Where's the fasten? It's going to be a third one. And it's going to be that last one. See, you put some fastener sign here, right there. You see this? And I'm not going to do it on the other side. This is why it's not going to be symmetric. I'm not going to cut it with the XF plane. But if it was same thing was done on this side, then you really have to take quarter of the model. When I say the same thing was done, means go to the plan and see whether the same thing happens on the left side and the right side. Okay, that's what I mean. And let's run it. Don't worry about this. We're used to this business of rotation. Every time we put server side there, it tells us about this warning message. Ooh. Clearance must be greater than 0. Okay, so something did not work well. Okay, so now we can fix this thing. There's a problem. Now, let me see what possibly could the reason be. Because what I read doesn't tell me much. Contact, these properties. Let me make sure everything is. Let's try it one more time. I want to read that message again, see what it said. Invalid clearance. Nodes of contact elements are so. What? 50 or clamped? Clamped. Okay, so what? Wait a minute. What did we do? Fit. Okay. You know, the easiest thing to do, in my opinion, is bite the bullet, delete, and delete, and yeah, those are gone. Okay, and let me try it again. I'm sorry, but these things happen. So let me see for a second. I created some here are the connections that I created. Let's see now, face and face. I just want to make sure it's the right faces. Bring it in the front. Let me hide this. Oh, which one is this? Oh, that's this face. The other face is the one that I hid. Okay, very good. Okay, so that's okay. Let's try the other one. The other contact, it was on this side. Okay, let's make sure this is right. Okay, so let me hide this. This face is that. Okay, fine. And this face is the inside of the hole. Well, that's good too. Okay, very good. Okay, so let's do that. Hide and this edges, by the way, I want to check the edges too. So let's go back here, see which edges I pick. This guy, wait a minute, this guy, where is it? Oh, this edge. Okay, this edge is that guy, and this edge is for that hole probably. Yeah, for that hole. So it's all right. Let's give it a try. Let's give it a try. Hide. Okay, let's make those contact one more time. So what we did here is contact with the first one, contact with the second one, pretty much what we did before, because I could not figure out anything wrong with it. I fastened this last one. Okay, and I anticipate the same message, but what I'm going to do, if I get the same message, I'm going to change my element to a different type, maybe parabolic, see if I get the same thing or not. If not, I will refer you to the video that okay, so let's say message. So let's do the following. Let me just try to choose a smaller element, maybe parabolic one, see what happens.
Professor?
Yes.
What is the difference between a fasten and a contact?
Fasten means you put adhesive there and they don't separate from each other. Contact means they can separate from each other if needed. Okay. Fasten means like being welded together. I didn't want to use the word weld. I did not want to use the word weld, but it's as if they're welded together. Contact is not welded. Yeah, so there's something else. Something else is cooking here. It's not a big deal. I will try to sort it out, and if necessary, I'll make a video and post it. Okay. Yeah. So it's unfortunate. I don't know why this thing is not working. Okay. Any questions? Any questions?
Professor, how come you didn't do edge to edge to the other side? Was it like in the
I
problem
could have.
statement? Or
No, I said that this is what I've got. You have to make some assumptions. In other words, if necessary, go to the plant and see how this thing operates. Are they welded on both sides or not? You know, so you really have to either make assumptions or see what the service condition is. If somebody actually took a welding gun and also welded the other side, then you should do that. You should weld at the other side. Yeah. Yeah.
okay, thank you.
You're welcome. Okay, folks, I'm sorry about this. So I will sort it out, and I'm sure I will sort it out, and I'll make a video for this particular segment, okay? And put it. It's already there somewhere. I have to go find it. It's not in your playlist, but I already did this thing with Symmetry a few years back. So I'm going to see if I can grab it there and put it up. If there are no questions, the next time that I'm going to meet with you guys is going to be your lecture coming up on Friday at 10:30. More of these. As you can see, they're more involved. And just remind you, I'm going to say that, you have to send us the product, all the parts that are used in that product, and the analysis file too. In the case of homework, you also need the PDF thingy. All right. If there are no questions, let's go home. If you have any questions, I'll be glad to hang around. I'm not gonna record this thing though. Let me stop the recording here. What is this? Stop.